comma C is a y-intercept. So that's a good thing about the first one. And also we can use quadratic formula, right? Because once we put in ax squared plus bx plus c equals 0, we can apply quadratic formula. Or vortex form. And this h and this k is the vortex. Right? So that's the beautiful thing about this form. If we can write in this form, h comma k is a vortex. Or vortex, we have two kinds, depending on A. If A is positive, we get an upward parabola, the vortex is a minimum. If A is negative, we get downward parabola, the vortex is maximum. For factored form, it's easy to solve for zeros. So this tells us s comma 0, t comma 0 are x-intercepts, right? Or roots, or sometimes called zeros. By using zero property, right? We set this one to be 0. Using zero property, we get x equals to s, x equals to t. So s comma 0, t comma 0 are two x-intercepts, or the roots of this function, or zeros of this function. Anyone has any questions? You see here we have upward parabola, and this will only have one x-intercept, or one root. Right? So in this one, we should get x minus a number squared. And the second one, we have two roots. We have two roots. And for those three, the coefficient, leading coefficient is positive. So the letter A is positive. So we could have one root, we have two roots, or we have no roots, no x-intercepts. For downward, it's the same thing. We could have one root, we could have two roots, two x-intercepts, or no x-intercept. It doesn't intersect with the x-axis. And these two, this one, 3 and 6, have complex roots, right? The discriminant is negative when we apply quadratic formula. Let's see how to solve quadratic equations. Right? We want to use square root property. Right? So x squared equals 9. We can square both sides. When we square both sides, we get a positive and negative 3. Right? Because negative square root 3, negative 3 squared is also positive 9. Or we can use this. We can move, solving quadratic, we want to move every term to the left-hand side, leave the right-hand side to be 0. So we have x squared minus 9 equals 0. Well, this is the difference of two squares, right? This is difference of two squares. Because 9 is a 3 squared. Right? Let me use this one. So difference two squares, right? X squared minus 3 squared. So that can be factored as x plus 3, x minus 3. Solve it. We get x equals to 3 and negative 3. We could also use square root. When we use square root, what do we get? Oops. Sorry. If we square root, we get n equals to positive, negative square root of m. Because negative value square, also positive. So n is the square root of m, but could be positive, could be negative. So if x squared equals k, then x equals a positive or negative square root of k, right? So x squared equals 9. X is the square root of 9, positive, negative values. So positive, negative 2, 3. 3 squared is 9. Negative 3 squared is also positive 9. So let's do a couple examples. If you have x squared minus 16, we can split into x plus 4, x minus 4. Right, so we'll get x equals to negative 4 and positive 4. Or we can square root. So we square root, we get x equals to plus minus square root of 16, which is plus minus 4. X squared equals to 10, square root both sides. So this is short for square root. So x equals to plus minus square root of 10. X squared minus 50 equals to 0. X squared equals to 50. So x equals to plus minus square root of 50. Well, 50 equals to 25 times 2. Square root of 25 is 5. So the simplified version is plus minus 5 radical 2. Anyone has any question? Let's see this one. 2x squared equals to 98. Of course, we want to divide by 2 first, right? So let's get rid of this scalar 2. Divide by 2 on both sides, so x squared equals to 49. Then x equals to, let me just add one more step. Plus minus square root of 49, which is plus minus 7, right? Or if we start with this, by 41, we want to move 41 to the left-hand side. We move 41 to the left-hand side, it becomes negative, right? So we get, oh, actually this is saying we want to move the negative 8 to the right-hand side. Then it becomes 41 plus 8. So that becomes 2x squared equals to 49. We divide by 2, x squared equals to 49 divided by 2. Then x equals to plus minus 7 divided by square root of 2, right? Let's use this. Let's use this one looking better. Plus minus, oh, I don't have a fractions, divided by square root 2, right? Or even better, we write this way. We rationalize the denominator, right? We rationalize the denominator. Anyone has any questions? Let's see this one. 3/4 b squared equals 108. So we would multiply 4 over 3 on both sides. Because 3/4 multiplied by 4 over 3, we get 1. So 108 times 4 over 3. So 108 divided by 3 can be divisible. Yes. So that's 36. This is multiplying, right? So 108 divided by 3. Think about 3. 3 is 9. 18. 3 times 6 is 18. So 108 divided by 3, that's 36. 36 times 4, y equals to 9. So this is something missing, right? 36 equals 4, we could think that's 6 squared times 2 squared, which is 144. 144, isn't it? Yes, which is 12 squared. Right. Then what does b equal to? B equals to 12. So this is mistake. So b equals to positive plus minus 12. Oops. Okay. Because we have 3 over 4. We could think divided by 3 or 4 on both sides, or multiply by its multiplicative inverse. Multiply by 4 over 3 on both sides. So 108 times 4 over 3, we could think, let me write one more step. I think that's 108 divided, we'll just write 4 first, 108 divided by 3, right? 108 divided by 3 is 36. So get 36 times 4, which is 144. 144, which is 12 squared. So B equals to plus minus 12. Anyone has any question? Let's see this example. Well, 1 minus 2 squared equals 48. So we can square root both sides. When we square root both sides, we get a 1 minus 2 on the left-hand side. Always plus minus 2 values, okay? Plus minus square root of 48. Well, square root of 48 can be simplified, right? 48 equals 16 times 3. Square root of 16, which is 4. So that's plus minus 4, that equals 3. Then we move this negative 2 to the other side, become positive 2. So become 2 plus 4, that equals 3, and 2 minus 4, that equals 3. So we can read them together in this shorthand. Anyone has any questions? Yes, Kiana?
But can't you square root the 4 as well, considering that it will be 2?
Hold on a second. Why you want to, which one, which 2 you want to square root? No, okay, you see from here, we square root from here. We square root both sides. So this one square root becomes 1 minus 2, right? Because square and square root cancel each other. Then we square 48. So we get a plus minus 2 values. And 48 can be divided by into 16 times 3. Square root of 16 becomes 4. Then what do? We just move this negative 2 to the other side, become positive 2. 2 plus minus 4 that equals 3. We don't need to square root anything else. Does this make sense? Okay. Okay. Thank you. Anyone else has any questions? One thing to remember is when we square root, the one side has to be plus minus 2 values. Because when we square negative values, it's also positive. Let's see this one. So we square root both sides. Then the left-hand side becomes y plus 3/4. The right-hand side becomes plus minus square root of 7 over 16. Right? We know square root of 1 over 16, that's square root of 1/4. That's just 1/4. Right? Then we move this positive 3/4 to the other side, becomes a negative. So y equals negative 3/4 plus minus square root of 7 over 4. Because we have a common denominator of 4, maybe you can write them together as negative 3 plus minus square root of 7, all divided by 4. Any questions? Let's see the next one. This one, the square term has a coefficient 9, has a scalar. So what do? We want to get rid of this 9. How do we get rid of? We divide 9 on both sides, right? So this one divided by 9, we just get 3z minus 2 squared. This one divided by 9, we get a 9. So the equation becomes this. Now we can square root, right? There's no number before this square now. We can square root both sides. So the left-hand side becomes 3z minus 2. The right-hand side become plus minus square root 9, which is positive 3 and negative 3. So then we move this negative 2 to the right-hand side. So 3z equals 2 plus minus 3. Then we divide it by 3 on both sides. So z equals to 2 plus 3, which is a 5. 5 divided by 3, right? Maybe I should write it in two cases. 3z equals 2 plus 3. Let me write this in two cases. Plus 3. Then we solve, we get this, right? Another situation is 3z equals to 2 minus 3, which is negative 1. Then z equals to negative 1 over 3. So we have 3z minus 2 equals to plus minus 3. 3z equals to 2 plus 3, which is 5. 5 divided by 3, one solution. Then 2 minus 3, negative 1. Negative 1 divided by 3, negative 1/3. Anyone has any question? Let's see this one. We have a number before the square term, and then we have this add 3. First, we want to move this add 3 to the other side, or we minus 3 on both sides. Right, so 57 minus 3, that becomes 54. How did 5 over 3 become 1/3? No, that's 2. Okay, 5 over 3 is the first one. You see here, we have 3z. Maybe I should write it in two cases. Right? This is 3z minus 3 equals plus minus square root 9. That means 3z minus 3 equals plus minus 3. So that means 3z equals to plus 3, which is 1. 3z equals to 2 minus 3 second. Okay. If 3z equals to 2 plus 3, that's z. Okay, let me just write it one more. 3z equals to 5. So we divide by 3 on both sides. So z equals to 5 over 3. So this is one solution. The second solution is 3z equals to 2 minus 3, which means 3z equals to negative 1. We divide by 3, z equals to negative 1 over 3. The two solutions. Does that make sense? Okay. Okay. So for this one, we just move 3 to the other side first, become negative. 57 minus 3, that's 54. Now we want to get rid of this 2. We divide by 2. So we have x minus 2 squared equals to 27. Now we can square root. Right? Now we square root, we get x minus 2 equals to plus minus square root of 27. Well, square root of 27 can be simplified as 27 is 9 times 3. So square root of 9 is 3. So that's plus minus 3 radical 3. Then we move this negative 2 to the other side. I should write one more step. So x minus 2 equals to plus minus 3. Right? Then we add 2 on both sides. So x equals to 2 plus minus 3 radical 3. Anyone has any questions? Okay, let's keep going. So let's see this one. We have 3 terms on one side, 1 term on the other side. What do? We move 16 to the other side. We have this 0 term. Right? Then 1 minus 16, that's negative 15. Now we want to put this in a factor form if we could. right? If not, we use quadratic formula. So how do we put it in a factor form? So we're thinking, okay, I have to work with 4, with negative 15, somehow play with their factors to get a positive 4. Right? So 4 can be factored as 2 times 2. Negative 15 can be factored as negative 3 times 5. Now I could think, okay, if I make 2 times 5, positive 5, then 2 times negative 3, I see 2 times 5 is 10. 2 times negative 3 is a negative 6. So that's bingo. So that means 2 times 5 is 10, minus 6 equals to plus 4, the middle term. If this is too complicated, forget about it, all right? Just use the quadratic formula. I'm going to show you the quadratic formula later. So that means if I have this pair, I pair these two, I pair these two. That means I have 2n plus 5, 2n minus 3 equals 0. Right. Then by zero property, okay, so this is by zero property, I can split this to be 0 and this to be 0. So if this is to be 0, I solve, I get n equals to negative 5 over 2. Or the second factor to be 0, I get a solution 3 over 2. So 2 solutions. Anyone has any questions? Okay, let's see this one. Similarly for this one, we want to move 125 to the other side, becomes negative 125. 81 minus 125, that becomes negative 44. Okay, then we see 4, 36, 44, they all have factors of 4, so we divide by 4. Divided by 4, the equation becomes x squared minus 9x minus 11. Now this is not factorable. So what do we do? This is not factorable because 11 is a prime number. The only two factors it has is 1 and 11. But the difference between 11 and 1 is 10. If this number was 10, we could make this into a factor form, but it's 9. We cannot. So we use quadratic formula. Quadratic formula is x equals to negative b plus minus square root b squared minus 4ac divided by 2a. So what is a here? A is the number before x squared, which is 1. B is the number before x, which is negative 9. C is the constant term, negative 11. Right? A equals 1, B equals negative 9, C equals negative 11. So first, let's find b squared minus 4ac. B squared minus 4ac. Well, it's b squared, negative 9 squared, which is 81. 4 times a minus 4 times a times c. 4 times 1, which is 4. 4 times the negative 11. The negative become positive. So get 81 plus 44. Excuse me, which is 125. Okay. Now let's enter square root sign. That's b squared minus 4ac. So square root of 25. Let me use this one. Square root of b squared minus 4ac. So in this case, it equals to square root of 125. Right, let me change this. 125. So square root 125 is 5 radical 5. Okay. Now putting into this negative b plus minus 5 radical 5 divided by 2a. A is just 1, so divided by 2. And b is negative 9. So negative 9 become positive 9. So we get 9 plus or minus 5 radical 5 divided by 2. So we get two solutions. One is 9 plus 5 radical 5 divided by 2. Second one is 9 minus 5 radical 5 divided by 2. So this is to apply quadratic formula. So this probably is the simplest way. You don't have to remember anything. Just, figure out A, B, C, plug into the formula. Anyone has any question? So that's all for today. That's all the material for today. And anyone has any questions about this, about solving quadratic formula, solving quadratic equations? Okay, you can use a factor form, you can use difference of two squares, or you could use quadratic formula. I think a quadratic formula probably is the most useful one. For some of you are late, right? So that's today's material, which is in chapter 9, section 1. So quadratic formula probably is simplest one. You just want to put the equation into a standard form, ax squared plus bx plus c equals to 0. All right, it has to be this, has to be, let me make sure. So this has to have this form. All right, let me write on this side. So this cannot be factored. So to use quadratic formula, right? For, this is very important, for a squared, let me write this. It has to have this form, all right? Ax squared, a is a number before x, b is before x squared, b is a number before x, c is a number by itself, okay? Has to be in this form. Okay, has to be in this form. In this form, you see the other side has to be 0. Then the number before x squared is called a, the number before x is called b, the constant term is called c. You have to put in this form, then use the quadratic formula, apply to this. All right. Anyone has any questions? Again, for some of you late, the statistics for, oh, 2 people already left. I saw it was 30 now. Oh, no connection. No connection for some. I know some of you have bad connections. For exam 2, the highest grade is 100. So this person get full credits. And then next, we have some 98, 97, 96, 95, 94, so on and so forth. So that's on the higher end. On the lower end, some of us are not able to take exam. And let me know if you still want to take the exam. And some of us have a bad connection. And the grades is like under 20, about 20, about 30. If your grades is like in this range, around this, and if you had a problem with your connection, internet connection problem, let me know. All right, let me know. I'll talk to the coordinator to see if it's possible for you to retake the exam 2. All right, and If you do get a very bad grades for exam 1, exam 2, that means you really have to work very, 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 very hard for 3 more weeks before the final comes in. The final will be in person, on campus, and I will announce the time and room as soon as I get it. All right. So make sure you study. You know, the material is simple, and we still have 3 more weeks, so you still can catch up. All right.
Professor, for the final exam, will we have a review that's not on my open math? Like, will we have a review in class?
Yeah, we will.
Okay.
Just like exam 1, exam 2, you have to do your work. You have to try to complete the review section.
Right.
Then you bring your question to class. All right, we can talk about the questions
Yeah,
you
but
have.
I kind of noticed that the reviews like don't really like focus on what's going to be on the exam. The reviews are just like a bunch of questions. Like, yes, some of them are on the exam, but I feel like the review, like, when we're like going over the final, will you kind of like help us know what we should focus on, or?
You know what? I'm not able to remember for this class. I'm just listed as a tutor. The coordinator, he's handling everything.
Okay.
I don't really have access to it. I'm so sorry.
No, it's okay. I was just curious. Thank you, Professor.
You're welcome. Okay, yeah, that's all for today, the material wise. If you think you can, if you don't have any questions, you can go ahead, start your homework. All right, if you do have questions regarding this material or exam 2 or something else, I'm still here. Okay, I can talk to you. But let me stop recording.